started it.
Okay. Hi, my name is Kana Hashimoto, and as you see, I'm not an engineer. I'm just an HR. And I was handing out some drinks outside, but since I got to 10 minutes before Mr. Matsumoto's speech, so I'd like to talk about my company, business, and also culture and structure. So our company profile is our company named Akatsuki, and we are located in 2 countries, Tokyo and in Taiwan, established in June 2010. So it's been 5 years for Tokyo office, and it's been a year for Taiwan. And our employee is over 200, including a contractor. Our business is the smartphone service development and also social network application development. And CEO is Shiota, and COO Koda. And actually, Koda is the CEO in Taiwan office as well. And they both have the same background in engineering. And Shiota was used to at the DNA, and Koda was worked at the Accenture. After retirement, Shiota and Koda co-founded Akatsuki. So our mission is making the world happy with the power of the games. We dream of a society where people do not only work for money, but also work for personal satisfactions. So we set our goal as to become a representative company of all ages using the power of games. And I believe there's 2 areas, which is gamers and entertainment, and the other is the gamers service for real life. So in this area, gamers and entertainment, we are actually pretty succeeded in this area. We stayed in a block, and for this year, we released new titles and our overseas expansion to Taiwan, and we are aiming to achieve higher goals this term. So now we are going to move our next step is gamers service. We are thinking about using a game power to solve problems in everyday society, such as education, work, and child raising, or healthcare. So we can't make our people excited if we are not excited to working. So that's why our CEO is more focused on working environment. So we have a vision, which is happiness through the relationship and growth. So we have some cultures, which is relaxing environment and communications, self-development, and also our things for each other. So I like to, So since we are seriously working on this environment, so we received an award for the 2nd year in a row, such as 2050 Best Company in Japan. And I'd like to show you guys some pictures of our company. This is a Tokyo office, and we have 5 floors and 200 members working here. And this is a Taiwan office. We have 1 floor, 40 members here. And I believe you guys already have a reflect of our company cultures, but I like to pick some. We have some barriers events, such as AKB events, and this is for communication, like we are playing Wii U together or going to ice skating sometimes. And also, every morning we have a time to chat each other, just like what happened to you in 24 hours. And also, we have a chance to go to Japan for training. And our company willing to support you to buying some books as well. But we don't think it's a clever idea that only you are developed. So we love to share some information, what you have and what you learn. So, and also we are not forgot to thanks for each other. We are celebrating all members' birthday, no matter you are part-time job or contractors. So actually that's it, but hope you guys are interested in Akatsuki, and we have a booth outside, so if you have an interest in our company, you can just beep beep your card outside. Okay. So, and also I very appreciate this great opportunity to cooperate with the Ruby conference this time. Thank you. Thank you for listening.
Technical-centric conferences, the very good attitude of the Ruby programmers here. And today I'm going to talk about the lazy programmer, or programmer's laziness, which is the one of the three virtues of the great programmers. So let me talk about the identity. So finally, so we Japanese don't have the direct translation of the identity in Japanese, but I'm not going to talk about the object identity as in the Ruby, but I'm going to talk about the self-identity. So what identify ourselves? So who are you? Who are you really? So we are programmers or hackers, people who make impossible possible, at least we want to be like that. And then I myself is a language designer. Have you ever seen other language designers before? Like, say, Guido of Python, or Lariwall of Perl, or maybe Rasmus Leldorf of the PHP, or maybe other person. But I encourage you to design your language. So I encourage you to be a language designer, because our Dave told us, the size of the cup reflects the size of the body. Anyway, the quote, programming is a process of designing your own DSL. So the programming is kind of the building up your own DSL for your application. So at the very end, you describe your application in your DSL. But having libraries, frameworks, or the routines, classes, methods, all of them are a process of designing your own DSL. In that sense, every programmer, every application implementer should be a designer of your own DSL. So I want you guys to be aware of being a language designer when you program. And because interface is fundamentally a language, so considering how language works is very interesting things. And the design is very difficult task. So there are tons of languages out there, programming languages. I don't know, the TOB index, which is the popularity ranking of the programming language, it has the 150 entries. But not only that, there are thousands or maybe tens of thousands of programming languages out there. So most of them are very unpopular. Maybe you don't have, you haven't heard anything. So there are internet sites named Catalog of Programming Language and Interpreter and Compiler. And that site contains the 5,000 programming language entries, 5,000. And we have 3 Ruby languages in there. So the very few programming languages succeeded. And maybe 10 or 50 programming languages maybe you are using. So what makes the difference? What's the difference between the very popular programming language like Java or PHP or Ruby, and what's the difference between the language of the popular and the language of the unpopular? So the first, when I tried to create Ruby, the programming language, so I didn't know about the, what? I think something wrong with yeah. Yeah, I didn't know about the what makes language popular. So when I started designing Ruby, I didn't mean Ruby to be popular. So I just wanted to create my own programming language as a hobby. So I didn't think about being popular, but I want to create my own programming language and then my ideal programming language. So I didn't know about what makes the difference at the time when I designed Ruby. So I vaguely have an image in my brain about the good programming language, the good virtue of the programming language, but I couldn't explain that in the concrete sentence. So I have only had the vague image of good programming language. So I didn't fully understand the nature of programming back then. But we had rescue, so although I couldn't express my feeling and my ideas of good programming language, but the other guys did. These guys, the programmers, Dave Thomas game. And these guys, in 1999, I guess, they found when surfing on the internet, these guys found Ruby. So then they started to play with the programming language, play with Ruby, and they love it. So they started to say proselyting. They introduced the language to others. Then they wanted to create website. They created the websites of Ruby, and then they wrote a book in only 6 months. That was amazing. So in the process of these their work, so Ruby gradually got popular. So in those process, the Dave Thomas again introduced the good aspect, the good attribute of the Ruby programming language, which is these two. One is duck typing, the second is dry. So let me introduce about the duck typing first. So duck typing is like this. No, this is typing duck. Duck typing is this. This, okay. No matter what inside, so when it walks like duck, quacks like duck, we consider it as a duck. So this is a fundamental concept of duck typing. So it must be duck, quack. So this is the essence of object-oriented programming. But think more deeply. So we don't classify object. So we don't care about what class it is. So we just care about the behavior. So we don't care about animal, mammal, human stuff that we have seen in the all object-oriented programming books. But that's crap. But we care. We don't check type. We don't check type. We just ask to do this, do that. Then they respond. So that kind of behavior is the fundamental essential of the object-oriented programming, at least the object-oriented program in the dynamic typing, dynamic languages. So we don't care about the inheritance. We don't care about the structure. We just care about how it behaves. So we can ignore the inside detail. So we ask computers to dispatch, so to choose what to do about according to the message or name of the method. So we don't have to work. So we don't have to care about the type checking. We don't have to about the method dispatch. The computer will do. So because we are lazy, so we must be lazy. So the reason of we have computers, so because we want computers to do tasks for us. So we should not work too hard. So let computers work. Because we're human, the master of the computers. So we want computers to work. So I take lazy way. So I want computers to work. That's why I create Ruby. Just because I want to do more things done by computers. So it's a spirit of duck typing. So the spirit of duck typing is being lazy. Understand that? So the second one, dry. You know about the dry principle? The dry stands for the don't repeat yourself. It is coined by Dave Thomas. And we avoid duplicates. And avoid redundancy. And avoid copying and paste. This is the spirit of dry. Because redundancy and copy and paste are bad. So because when you copy the code, you spread bugs all over. So when you fix the bug, so if you have duplicates, you have to fix the bugs where there and there and there. If you have 10 copies, you may fix the 9 of them, but if you left one of them, so your system still has bug. So that's the problem. So besides that, so we are lazy, so we are too lazy to maintain duplicates. So the dry principle is the principle to help us being lazy. So in summary, those two principles, the very important in Ruby, which is mentioned by the Dave Thomas, was the spirit, reflect the spirit of laziness. So we have been working so hard. So I started developing Ruby in 1993, which is 22 years ago. And we have been working so hard for the last 20 plus years to make Ruby better, fundamentally to reduce our burden and to become more lazy. I worked so hard to be lazy. And 20 years later, the time flies, situation has changed. So 1993, we have Ruby for scripting. We don't have the web back then. And the Ruby is for small programs. And our computers have single CPU in it. And in early 90s, we have in the process of gradually moving from procedural to object-oriented programming. But 20 years later, in 2015, we have web applications. The main field of the Ruby model is the web application, and it tends to be a huge programs. Like including the Ruby on Rails, the web application framework, we have, I don't know, maybe thousands or maybe tens of thousands of code for our web applications. And our computers tends to have the many cores in it. So the dual core, quad core, octa core is not that rare. So it's quite popular. Or for servers, we have 32 cores in the computers. So we have multi-cores. And so everyone is using our computers and or smartphones. So we have very, very high traffic. And then in our 21st century, we are in the process of moving gradually from object-oriented program to functional programming. So according to the theory of evolution, so we have to adapt to the surrounding environment or we will be extinct. So maybe it's okay for you guys even if we'll be extinct. So you can move on. So maybe you have Python, or maybe you have Clojure, or maybe Swift, or any other language. But for me, this is a very critical problem. If Ruby dies, I'm going to die. That's the problem. So we upgrade our products. We have to upgrade our products, really. So, but in the process of upgrading, we have to beware of SSS. That stands for the second system syndrome. As time goes by, our systems will go bigger and more complex. So that happens all the way, all the time. And when we become sick of complex systems, the second system syndrome will come. So we tempted to throw away everything and create new things from scratch. That is the second system syndrome. But most of the time, when you throw away the past and start from scratch, the new system will fail. And this second system syndrome, I understand your feeling. You want to create re-implement the cleaner, better system from scratch. That's a nice. That sounds nice idea. But at the same time, that happens all the time. But most of the time, it fails. And second system syndrome comes very often for programming languages, just because the programming language has longer lifetime than user applications. For example, we have Power 5 and Power 6. So the people get 6 of the Power 5. So they wanted to throw away everything and start from scratch in year 2000. And we haven't seen the official release of the Power 6 yet, after 15 years. And recently, 3 weeks ago, I had yet another Pro conference in Tokyo, and the Larry Wall himself declared we will have the Pro 6 in this Christmas. Whoa! After 15 years of development. But I foresee we have very hard transition here after. And we had a Python 2 and Python 3 problem. So we had the Python 3 for years, but many of Python users in the Python community still use Python 2, stick with the Python 2, just because the Python 3 has a huge incompatibility. Ruby is no exception. We had a problem now between the Ruby 1.8 and Ruby 1.9. But we've done better than other programming languages. So we re-implemented the virtual machine in 1.9, and we added the multilingualization, which we call it M17N. But we had to create some kind of the compatibility gap. So it is required to fix something in the programs that runs on 1.8 to port to 1.9. But because of that kind of the compatibility gap, so we took a long time to migrate. Are you guys still? Is there any guy who's still using 1.8? You mean? No? Okay. Last week I asked the same question in Barcelona, Spain, and we had a few hands raised. Yeah, that's fine. God, don't use 1.8 anymore. Okay. So we have done better than other languages just because how can we overcome a second syndrome? So we had done in 3 steps, 3 principles. We have never thrown away everything. The first one, we have the virginization and the migration. So we have never thrown away everything. So we have replaced one at a time. So replacing virtual machine, so we created the extension of the new virtual machine as an extension, the native extension. So we call the new virtual machine as an extension, so that we can feed the program to that extension to run, so that we can compare the old virtual machine and the new virtual machine. So then, after working many tests, so when we can be sure that the new virtual machine works as old virtual machine, so then we replace the virtual machine. Or when we add string class, so we create the test suites for the string class, then we gradually replace the string class. So the replacing string class and the replacing virtual machines, and we replace the object representation. But we replace them one at a time with the test suites running. So we replace the garbage collectors, and so we replace step by step. So we haven't thrown away everything. So keep compatibility as much as possible. So, and we prepared migration paths from 1.8 to 1.9, or then 1.9 to 2.0, 2.0 to 2.1, and the current version 2.2. So in that way, so people are much easier to migrate from the old version to new version. And we never tried a drastic change. So, I was tempted many times to throw away everything. But, considering the number of the Ruby programming in the world, maybe more than 1 million of Ruby programs is running everywhere. So I had to give up some of the proposal, the change. So we had to be very conservative about adding new things. That's kind of, as a programmer, that's not fun at all. That making drastic change is very amusing and fun. But considering the result from that kind of fun is a kind of tragedy. So I had to give up some nifty, drastic, and dangerous change. The second one is versioning illusion. So think about the Pro. Pro had a version 5 and 6, and the Python had a version 2 and 3. But the Ruby had a version of the 1.8 and 1.9. that seems the transition, that makes feel the transition is small, so which is not though. But that kind of illusion probably helped the migration. Okay, this is not that important. Okay, 3. This is very important. Migration byte. So the moving 1.9 had a huge benefit. So by replacing the virtual machine, the same program runs maybe twice, or maybe in maximum 50%. The 50 times faster in some cases. In average, the new virtual machine ran 2 times faster than the old virtual machine. So even though you have to port your program to new version, but once you move to the new version, your program will run twice faster. So you want to pay that cost, the migration cost. But imagine that. So if you are told, so okay, our new version is cleaner, niftier, and in implementation wise, very easy to maintain virtual machine. So our new version is better for the core developer. So then but for that sake, you have to pay your migration cost. So you don't want to pay that migration cost just because that's not good for me. I don't care about the cleanness of the core or the virtual machine. But in Ruby, we provide a benefit for both of us, for the core developer and for the users. So that is a very good migration bite. So we provide performance. So that would be the very big motivation to moving forward. So, okay, again, rule of thumb of the second system syndrome is don't push too hard. So don't do drastic things. Then don't throw away everything. Then push softly. The improve gradually. And push steady. Don't stop. Just keep moving forward. So the compatibility is the key. So we had learned a lot from the 1.8 and 1.9 transition. So after that, we had the Ruby version 2.0 had almost perfect compatibility, except for fixing bugs. So some programs rely on the bug behaviors, but except that, we had almost perfect compatibility. Since Ruby 2.0, 2.1, 2.2, we had we kept our compatibility very much. So, but as time goes by, second system comes again. So that the recent years, since last year, we are discussing about Ruby 3. But we don't forget the rules. These don't push too hard, push softly, and push steady. So we started working on Ruby 3.0 by experimenting ideas. So we are not too hurt. Just because if I introduce some new feature, and it turned out to be bad or wrong or something unuseful, so it's quite difficult to remove that. So once I introduce new things, it has to be kept years, 5 years, 10 years, 20 years. So we have to experiment ideas. So there are experiments about Ruby 3 already. So, but we don't promise anything. But our ideas are classified in these 3 fields: the man-machine collaboration, and performance, and concurrency. So for man-machine collaboration, in the process of programming, we code. So the code is the communication from man to machine. And then we got error messages from machine to man. And then sometimes ID provides the better communication, like the completion, or maybe the better error message or something. So I'd like to introduce some kind of the proactive warning. So for the first step, Ruby 2.3, which is coming December, has the "did you mean" feature. So when you mistype the class or variables or methods, so the Ruby 2.3 will ask you about the "did you mean this or that" to check your misspell. So that is kind of the proactive or noisy warning. So that you can communicate better with computers in development of your program. So for Ruby 3, I'm thinking about the soft typing, which is the not gradual typing, not optional typing, but it's kind of like a global type inferences. So when compiler sees the this method and that method for this variable, I mean this object. So this object supposed to have this set of methods. So then, by collecting those kind of information, so you can infer the type of the object. And if you do something contradict to the existing information, so the compiler will tell you, so you have the contradiction in your object type. So you must make mistakes. So unlike the usual static typing with the type annotation, type declaration, so it will not cover 100%, but maybe it's 80–70% it will be covered. So that would be much easier for a Ruby programmer to find bugs in compile time. So the type declaration, so for Ruby, the type declarations are redundant. So because Ruby runs without type declaration right now, so we don't need type declaration to run. So it's against dry. So we are lazy. So we are too lazy to maintain duplication. So that's the soft typing. So the typing, soft typing, type guessing, type inferring without any type declaration. Static analysis, everything, and find contradiction. This is the vague concept of the future, the man-machine collaboration in software development with Ruby. The second is the performance. So the improving performance is not an easy task, but we are thinking about the JET, just-in-time compiler. And last year, we have granted the project named RuJet, which is the tracing JET compiler for Ruby. And it turned out it runs several times faster, 2–3 times faster. That's great. But at the same time, it consumes a lot of memory. And then these days, the memory is the first bottleneck. For example, especially in Heroku, the smallest dyno only has a 500 meg. So the memory consumption is very, very serious problem for Heroku users. So as a employee of the Heroku company, so the many people pay money for bigger dyno is good things, but for users, it's not good news. So I really stands the user side. I have to really stand for the user side. So we have to reduce the memory consumption. So we found out we cannot use the tracing JET. But almost dyno. So we will try the method JET, which is the different approach for just-in-time compiler. And the few weeks ago, the IBM offered their technology to implement JET for their JVM. So they try to open this technology to other programming languages like Ruby, Python, or other things. So we didn't discuss with them yet, but if they provide these technologies, we might have the better JET with less memory consumption and the better performance. So I'm pretty expecting of that, but I don't make any promise yet. So the third one, the last one, is concurrency. Many people complains about concurrency. Just because the computers 20 years ago, we had single core. So when I implemented the first Ruby, so we don't have to care about multi-core. So but right now we have dual core, quad core, octa core, or even the 64 core or something. So we really need concurrency right now. But we have the GIL, the Global Interpreter Lock, which is some part of the interpreter and some C extensions are not thread safe. So to avoid serious problem, we have the Global Interpreter Lock to prevent thread unsafe code from crashing. So, but we are still working on to make Ruby better concurrency and to implement thread safety. But you know, the thread is too complex. Probably it's too early for human brain. We haven't evolved enough yet. So we need for more abstract concurrency model. So this is my plan. My big plan for removing jail is to add more abstract concurrency models, like, for example, actors, and add warning when using strict directory, then remove jail. And then we have thinking about the several better concurrency model. For example, the actors, or ownership models, or stream or pipeline model. So the actor model is provided by, say, Erlang, Elixir, and partly Go is providing actor model. And then what? Ownership model is the kind of like a Rust memory management model. It's only the thread that owns object can modify the object. So from the other threads, so you cannot modify the object, so that only one thread can modify the object, so that you don't have to worry about the changing state, about the object changing or the object modification. This is the second one. Koichi is working on this model. And I'm thinking about this is streaming the pipeline model. And today I'm introduce about the streaming model. So in future Ruby, this is a event model. This creates streams from standard in to standard out. So this new operator connect to tasks or I/O. So this is the simple echo server. So we create the server socket for port 8007, then connect it to the stream map, which executes from a socket from the server socket. So it receives the server socket, then connect the server socket. It received the client socket. In the name of sock, then connect sock back to the sock, which represents the echo. So this is a very simple echo server. This is the client side. So create a client socket, then connect standard in to client socket to the server. So you send the input from the keyboard to socket. Then you receive the socket, then output to the standard out to print out to the console. This is the very simple netcat client. So we will introduce this new kind of operator. It's kind of like Elixir's pipeline operator. In fact, I stole from it. The dot operator creates the pipeline. The pipeline is the list. Pipeline is the connection, the chain of streams. Then the process one by one. So then enter event loop. So unlike shell, this only creates the pipeline, not the process. So if in the shell script, if you connect to command line process, two commands by pipeline, so it runs. But in stream, it only creates the pipeline. At the very end of the program, it enters into the event loop. Then the data that run through the pipeline you prepared. It's would. So the normal Ruby program to create the pipeline, then it enters into the thread-safe event-driven loop. It's kind of like a Rube Goldberg programming, like to create the pipeline first, then push the ball into the pipeline. Or maybe making dominoes, create the domino lines, then push the domino. So the important thing is that it's in event loop mode, so everything is safe. So that means that you cannot modify object in that mode. So everything is immutable after you enter into the thread mode. So that provides the object immutability, so that you don't have to worry about the deadlock or the information sharing. So everything is immutable. To experiment this concept, I created some experimental language, the different language from Ruby, so named Stream. So you can find streams in this repository, so you can check out. It's okay. I notice you. I warn you. It is a toy language, a proof of concept language, but it's quite fun to work, at least for me. So we are still experimenting these ideas. I don't know which one will win. I mean, the Acta models may win, the ownership model will win, or streaming model will win, or maybe we might provide some of them. I don't know, but at least we are experimenting. So at the same time, we make no promise about the future. So I understand you have questions. So when will it be available? But the answer is I don't know. But let us talk about Ruby 3.0. To make gradual step, so because we have to conquer second system syndrome, so we want to throw away everything for Ruby 3. Okay. So we replace everything. We make forward step by step. So we make things forward to create better future or stimulate the open source community. And while keeping compatibility, so we have to move forward to create the future and make Ruby better to reduce our burden and make us more lazy. So that is our mission. The mission of the core team, the language designers, and we will work very, very hard to be lazy. And happy hacking, 谢谢。
谢谢 Matz 桑的分享。那请问一下，在座有没有人有任何的问题想要发问的，可以举手发问。Anyone has any question? No question.
No question.
Thank you very much.
Thank you.
那我们再一次热烈掌声，谢谢 Matz 桑。
Hi. Matz, thank you for your talk. I have some questions, actually. I just kind of missed the opportunity. So one question I want to ask about is, so with the dynamic nature of Ruby, we often see in larger applications where there's a lot of code that's being mixing around, and it's really hard to trace sort of where a particular method is coming from without actually going to the debugger and then using things like method source. And then we also see a lot of cases where in larger applications it's really hard method definitions gets overridden with intentionally or unintentionally. So you also mentioned sort of the man-machine interface that you want to start building in Ruby 3, and so I'm wondering what sort of thoughts you have on that, the ease of Ruby being able to mix in around methods and sort of the potential drawbacks for that in a larger application. Thank you.
Yeah. Yeah. We were working, for example, that kind of the did you mean gem? So we are working on the giving proper information for debugging. So maybe we can do something for that providing backtrace or anything. So and if you have any idea to make Ruby better, especially for the man-machine collaboration, so tell me and then please submit to the bugs on ruby.org, rubylang.org to make Ruby better. So so I created Ruby, so I started Ruby, but the Ruby is not a single person project no longer. So we have the tons of contributors, a lot of ideas from the contributors. So maybe you have just anyone in this audience can have the idea to make Ruby better, or to help whole the community to better. So think about be a language designer, be a part of language designer. So try to make Ruby better by creating gems, by making proposals, or making new frameworks or new programming model. We are very welcome for your contribution and to the communication with you guys. Thank you.
Any more questions?
So I want to ask for the concurrency part. Have you considered a more ambitious approach to break the boundary between machines? So for the concurrency, have you considered distributing different tags between multiple machines for Ruby 3.0?
Well, of course we think about that, but at the first we have some kind of the concurrency in the process, just because this is the basis of the concurrency, and by using that we have the cross process or cross machine the distribution. For example, we already have something in the DRuby, distributed Ruby, which is help for the distribution. But that object model might not work well with new models. So after we provide the concurrency model, so maybe we have to extend that model to the cross process or cross computer concurrency. So we have to. So in the process concurrency is our first step for the global concurrency.
Last question， 最后一个问题，还有没有人要问问题呢？最后一次机会哦。
I wish I could understand Mandarin.
That's a last chance to ask a question to you, basically. 好，时间结束了，那我们再一次热烈掌声，谢谢 Matz 桑。
谢谢。